In this video, we are going to look at some applications of logarithmic functions. So the first problem that I want to look at is how you actually evaluate a logarithmic expression if your base is something other than 10 or the natural logarithm has a base of e. So some calculators will have a key on it that allows you to put any base and evaluate any type of number. So certainly if you have that key, then you would just go in this case and type in a fraction of 1/8 as your base and the decimal 0.669 and hit enter. However, if your calculator does not have that, you have to use something called the change of base formula, and that means you're going to punch it into your calculator like this. So you always take the log of whatever this number is here on top, and you can do that in base 10 like I've done here, or you could do base e, and then you divide by the log of the original base. And so just make sure if you're working in base 10, you do both base 10 on top and bottom. If you're going to do base e, then you do a natural log on top and bottom. So to 2 decimal places, I can see that when I punch that out, this would be equivalent to 0.19. Okay, on this second problem, we are dealing with pH values of concentration. So we do have to have a formula for pH, which I'm giving you down here. And so they tell us that the pH is defined to be the negative log of, and in this represents the concentration of those ions that are in the solution. So notice they're telling me that I've got a certain solution and it has this concentration of 1.17 times 10 to the negative first. So if I'm asked to find its pH, I will take the negative log of that concentration. So I'll have to punch in 1.17 times 10 to the negative first and take the negative log of that. So that's what I'm showing you I did here. I just used the Desmos scientific calculator. They're asking me to round my answer to 1 decimal place in this case. So if I look at my answer down here, that would have a pH value of 0.9. And notice they go on to tell us, just so we understand more about pH, that when a solution has a pH less than 7, it's said to be acidic. Whereas if the pH is greater than 7, it's said to be basic. So this is definitely less than 7, so we would be talking about something that is acidic. Okay, on this next type of application problem, we are dealing with sound. And so if we are given that this I sub 0 is equal to 10 to the negative 12 watts per meter squared, and we're being asked what is the intensity of the sound for which the decibel level of the sound measures 141. So down here, we are given a formula for measuring the decibel level. So it tells us that that decibel level, which they're telling me was the 141, is equal to 10 times the log of whatever my I, which is my intensity, is, divided by, or the intensity of sound, divided by the intensity of the, what they called the discernible sound, which in this problem they told me was 10 to the negative 12 watts per meter squared. So I'm going to have to solve this equation so that I can try to find I. And the first thing I would do is divide both sides by 10 to get that to cancel. So I'd be left with 14.1 is equal to the log of my I divided by 10 to the negative 12. And at this point, I would change it into log form. Now, when there's not a base given here, and they've spelled it log, it's understood to be a base of 10. So if I change this into exponential form, 10 is my base. I'm going to raise it to the power of 14.1, and then that has to equal to I divided by 10 to the negative 12. So notice, in order to get I by itself, I am multiplying both sides by 10 to the negative 12. And so it cancels here. And whenever you have common bases, then you can simply add their powers. So negative 12 plus positive 14.1 would leave me with the power of positive 2.1. So then I got on my Desmos calculator, typed in 10 to the power of 2.1, and noticed that gave me my intensity level, and they wanted 3 decimal places on this answer, so I would say that intensity level is 125. Point, the 5 here will tell the 2 to round up, so that would be a .893 for my final answer.